two compounds. The first is and the second is. So as you see, the first one is C double bond R, and this is aldehyde, and it is exactly what? Ethanol. Good. So this one is ethanol, and the second one, since it has a functional group COO2, this is carboxylic acid, and it's exactly butanoic acid, since it has 4 carbon atoms. But the question here is not what their names or what. The question is just, do they have same empirical formula or molecular formula or molar mass or what? Okay, we're gonna see now. Do they have same chemical properties? No. Why? Because if one of them, if the group here is different, so that means they don't have the chemical properties, so it's not there. This one is aldehyde and this one is carboxylic acid, so that means they are different in their chemical properties. This is number one. Number two, molar mass. Molar mass, as we know, it is the mass of all the components. So that means here I have, just as you see, 2 carbon atoms, and here I have 4. And so that means here number of atoms is more than this one. So that means the molar mass will increase by increasing the number of atoms, right? So that means molar mass is not the same. So that means this one is not right. So that means now we go into 2 things, either empirical formula or molecular formula. Okay, we're going to try to find what is the molecular formula of both. The molecular formula of this one now, it's just, you mention the number of real atoms of the components. So here now we started by carbon. How many carbons we have? We have 2 carbon. Good. And how many hydrogen? Here you have 3 hydrogen, here is 1, so that means we have 4 hydrogen. And how many oxygen we have here? As you see, 1 oxygen, so we write it 1. So this one now, did it give us the real number of atoms of each element in this compound? Yes. It gave us 2 carbon as their 2 carbon, and 4 hydrogen as their 4 hydrogen, and O there as O there. So that means this one is molecular formula. Good. What is the molecular formula of this one as well? Now I'm talking about molecular formulas. So molecular formulas here, just how many carbon atoms are there? How many? Here is 3 and here is 1. So that means you have 4 carbon atoms. Good. And how many hydrogen? Here is 1 and here is 7. So that means you have what? 8 hydrogen. And how many oxygen? Here we have 2. As you see right here, O2. So that means did this formula give us the real number of carbon and hydrogen and oxygen in this molecule? Yes, it did. So that means in this question, this is molecular formula. So that means, do they have, now the question, do they have same molecular formula? No. So that means they don't have the same molecular formula. Now you go to check the last one, empirical formula. Empirical formula is the simplest form of the molecular formula. Okay, this one now, can I simplify it to get its empirical formula? When I simplify it, this is 2 and this is 4 and this is 1. Is there a number that is divisible by 2 and 4 and 1? Is there any whole number that is divisible by 2 and 4 and 1 rather than 1? No. So that means this is the simplest form. So that means this is now molecular formula, and it's also what? Empirical formula. It is also what? Empirical formula. Good. So it's both molecular formula and also what? Empirical formula. Okay, what about this one here? Can I simplify the 4 and the 8 and the 2? Yes, I can divide them by 2. What will I get? So this one now it will be C2, and here it's gonna be H4, and this one will be what? O1. You see? So this one now is the empirical formula. Is the empirical what? Formula, while this one is what? Molecular formula. Okay, now is this empirical formula of the butanoic acid similar to this one? Yes, it is. As you see, C2 and H4 and O2. So in this case, they have the same empirical formula, but they didn't have same molecular formula. They didn't have what? Same molar mass. Okay, so you go to choose here empirical formula as the answer. Related to structural formula, by the way, structural formula, just you order them as they are. You order them as they are. Like this one here, as you see, C2H4O. This one is molecular formula of ethanol. But if you need it to be structural, so that means it's going to be CH3, you write it this way, then C CHO. CHO. So in this case now, look here, now it gives us the number of carbon atoms, number of hydrogen atoms, oxygen, but regardless of how they are structured. But here now it gives us how they are structured. So this one is structural what? Formula of this aldehyde. This one is molecular formula, and since we cannot simplify it more, so this one is also called what? Empirical formula. So you understand that this is the answer, empirical formula in both.